What's up, everybody? Wanted to really quickly make a video walking through some of the facts and details behind the Intel C6i Ice Lake processor and how it operates on AWS, specifically EC2 instances. So in this video, we're going to walk through some of the facts behind the Ice Lake chip's performance. We'll kind of compare that performance to other GPU instances to better understand what the relationship between speed and cost looks like, and then we will finish with a quick summary of use cases in which the Ice Lake is a great thing to pick. So with that started, a little history, right? So the Ice Lake chip, also known as the C6i, is one of Intel's latest chips. It's very powerful, and in this video we're going to be comparing the 2x large instance in our comparisons with the GPU units. So really quickly, for those not familiar with AWS, there's a formatting. So everything to the left of the period is the name of the processing unit. So in this case, right, so the C6i, that's our processing unit, and everything to the right of the period is the size of the instance. So there's large, X large, 2X large, etc. And the bigger the instance size you get, the more resources you have. So for example, we are focusing on the 2X large, which has access to 8 vCPUs. A virtual CPU, if you recall, EC2 instances are a remote server that is provided to you by the AWS service. So the idea is the 2X large gets you 8 virtual CPU units, and it also gets you 16 gigabytes, which is very similar to gigabytes. They're just mathematically altered to match reality, right? So basically 16 gigabytes in memory, which is a really powerful, useful size. You can do a lot of things with this much resources. Specifically though, let's see how performing computer vision inferences stacks up for the CPU units versus the GPU units, which we have down here. So this column, this is our Ice Lake column. And the most interesting things to be paying attention to are first this one, second is this one, and then third is this one, which we're going to talk about in sequential order now. So what is this row right here? This row is our FPS. This is the frames per second at which our processing unit can process images and get computer vision results, right? So a process is you give us an image, we perform computer vision on it, and we tell you what's in that image, right? And the inference results are, I detected a car, I detected a person, whatever they may be. So in this case, comparing across the instances, they are all 2x large, and the only thing that changes is the processing unit and the GPU unit in each one. So let's walk through some of these results. First and foremost, we'll talk about speeds. You will notice that of the 4 instances compared here, that the Ice Lake is the slowest of the 4, which is okay because in a moment we're going to be talking about price, which is equally important. And the idea is that as you switch over to GPUs, right, so from this particular CPU unit, which is the Ice Lake, to the T4 NVIDIA graphics card, the speed does increase on the GPU, and as we increase the size of the GPU, it also increases in speed. But more importantly is speed increases, but it provides diminishing returns in relation to the price. So for example, between the lowest and the highest is about a factor of 10x, right? So the Ice Lake on-demand pricing is 34 cents. For the V100, which is our most powerful tested graphics card in this experiment, the price difference is about a factor of 10, whereas the speed difference is a factor of about 2, right? So that's always something to keep in mind, is that speed typically does not scale with price. And with that said, we can get an overall analysis of the speed to cost ratio down here in this final row. So for the Ice Lake, what you get for the price point to speed ratio is a rating of 152. We get this rating by just taking the FPS and dividing it by its cost. And you'll notice that the ratio of effectiveness, or price efficiency, or however you want to think about it, tends to decrease or slightly increase, I guess in this case, right? It goes from 94 to 95 and then back down to 40 with price. But the important thing here is that the trend kind of goes down and to the right, like so. So what this tells us is that if you're looking for an instance that has really great processing power at a reasonable price, the Ice Lake offers you more than enough features and functions and speed to get the majority of use cases done for an effective price. As you run into more niche sectors in which you have to really get specifically high complex video streams, multi-parallel video streams going on, you might potentially need more FPS. But in a general purpose setting, we're confident with saying that the Ice Lake chip does offer a better experience in terms of ease of use, price, and scalability in the long-term run of things. And if you want to learn more about the EC2 C6i instance, it's very easy to get started. All you have to do is essentially grab one of these instances and spin it up on AWS, right? So here I have a AWS EC2 C6i 2x large instance running. Once I have this instance running, it's just a virtual machine, so I could remote into it. I can get my application running on it. I can set up AWS batch. I can turn it into an endpoint. Whatever I want to do with it, I can serve customers at a really effective balance of speed to price here. And if too many customers start to interact, all I have to do is spin up more instances, and the more Ice Lake instances I spin up, the more cost effective I get. So as I scale, I save money and I serve customers. I hope this video has been useful to everybody. And if anybody has any questions or comments, please leave it in the blog post tied to this or the YouTube channel. And I'm looking forward to seeing those responses. Have a good one, guys. See ya.